One of the most important things during mobile application development is having and managing your users' data locally on the device. In the next few minutes, I will show you the pattern that we use to make sure that our users' information is in memory all the time on our device, and also make sure that it's readily available through a user service that you can access from any view model. We've used this implementation in all of our client applications because it is the simplest and easiest to manage. Stick around and you'll see what I'm talking about. Hey guys, welcome back to the new episode of Boxed Out. In this episode, I will be setting up the user profile and the functionality to sync that user profile into the customer application. If you've been following along, then you have the code needed to start. If you haven't, you can go to github.com/FilledStacks/boxedout and download the code. Once you have the code, you can open it up in Visual Studio Code. And once you've opened that code, you can run flutter pub get. This tutorial will focus on creating a user's profile on the backend and also syncing that user profile information when we log in or sign up into the account. So on our backend, what we'll do is we'll create a user's collection. We won't do that manually in Firestore. The code will do that for us when it creates a new document. This collection keeps the user's information, and since we are dealing with NoSQL, I don't have to set up the entire schema, and I can actually let the data evolve as we need new functionality. The first thing we'll do is set up our models that we'll require. We'll be using freezed and JSON serializable, so we'll add that into the pubspec.yaml file. For the dependencies, we'll add the freezed annotation and the JSON annotation packages. And then we'll add the generators into the dev dependencies. Then you can open up the application models.dart file. Then in the lib folder, we'll create a new folder called models. And inside of that folder, we'll create a new file called application models. To create a model easily, I have created these stacked snippets. You can find it in the link in the description, and to add that you simply add it into your Visual Studio Code under the Dart snippets. To create a freezed model with a JSON serializing functionality, we will type in frz.js. That will generate everything you need, and then we'll change the name of that model to user. We'll make the ID required, and we'll also add a nullable string for email. And before we generate the model's outputs, I also want to add the logger into the stacked annotation for our app. To get this functionality, we'll update stacked to version 2.1.0, and we'll update the stacked generator to version 0.4.1. Then we can get the new packages, and when that's complete, you can head over to the app.dart file, where we can now supply a logger to the property of the stacked app annotation. Now that we've added the logger, we can run the buildrunner build command. There's a few things that we forgot to do in the application models file. The first thing is to import the freezed annotation, and the second thing is to make this file part of the two files that will be generated once we run the buildrunner command. Freezed will output its generated code to a .freezed.dart file, and the JSON serializer will output its generated code to .g.dart files. When that's done, you'll see that you now have a logger that has been created. This logger will automatically log the function name that you are calling the logs from. This makes it easier to trace your logs and removes a lot of the additional boilerplate in your logging where you have to add the function name in front of your actual log information. And the second thing you'll notice is the two files that we made a part of the application models file. The freeze file has all of the data model functionality, and the .g file has the JSON serialization. Now that we have the models, let's go over the plan of getting the user into our system from the code side. The first thing we need to do is create a user document for the user that was signed in. There's two ways to do this. One is we create the user using a reactor function on the Firebase Cloud Functions backend. The second way is to create the user on our side and create a new document directly on the Firestore database. In this scenario, I like the second option because we'll need the entire model locally. So we'll construct our model and then create a new document in the users collection from our side. Next, we have to figure out where we are going to create the user and what's the logic behind creating a user. Let's go over the two use cases that we'll have currently in our app. When we create a new account, we want to create a new user using the user ID returned from Firebase. When we log in, we want to be able to check if there's a user document that exists with that ID. If there's no document, we want to create it for that ID. And then if there is a document, we want to download that user's information into the session. Because both of the cases above have the same final outcome, which is a document will exist and then be downloaded, we can write the logic in that way as well. We know after any of the authentications, login or sign up, we have to get the user's profile document. So we'll add that into our authentication view model flow. We'll wrap this functionality into our user service. But before we can create our user service to manage all of this, we need a way to communicate with the Firestore database. So that's what we'll tackle next in our implementation. Create a new folder called API under the lib folder. And inside that folder, create a new file called Firestore API. Based on the flow that we described above, we'll need to create two functions relating to the user. The first one is to create a user. This creates a new user document in the database using the ID passed in. The second one is to get the user, which returns the user from the users collection if the document with the ID exists. That's the basic functionality that we're looking for in the user service. We'll start by creating our Firestore API class, and then we'll set up our logger. The name that you pass into the logger has to match exactly the class name. That is what we use to pull out the function name that you are calling from and automatically add that into your logs. The next thing I want to do is set up the collection that points to our users collection. To get that functionality, we'll need to get the Firestore Database package. We'll add the Cloud Firestore package into the pubspec file version 1.0.6. When that's complete, we can import the package so that we can get the collection reference type. The users collection will be equal to the collection with the same name users. This will be the collection used whenever we need to reference the users collection. So one thing that I usually do is create a specific exception for a base service like this. So in the lib folder, we'll create a new folder called exceptions. And inside that folder, we'll create a new file called Firestore API exception. We'll create a class called Firestore API exception that implements exception. This exception will take in 3 values. One will be required, the message, dev details, and the pretty details. The message will simply be the message for the exception. Dev details will be any details that we can tell the developer experiencing this exception during debugging. And the pretty details is if we want to bubble this exception up to the user, we'll use the pretty details message from the exception to show that as our validation or our dialog message. We'll also override the toString function and then print out the message, and if there's any dev details, we'll print that out as well. Now we can get back to our Firestore API. The first function we'll tackle is to create a user. We'll create a function that returns a type future of type void called createUser that takes in a required user model. The first thing we'll do is log out that information for the user. Then we will add a try catch statement, and in the catch we'll simply throw a Firestore API exception with the message failed to create a new user and the error as the dev details. For the actual body of this function, what we'll do is we'll get a user document on the users collection using the user's ID as the document's name. And when we have that document, we will call set on the document and pass in the 2 JSON data from the user model. And when that's complete, we want to log out a verbose log that says the user has been created and print out the path of that document. The next function we'll create is to get the user. We'll create a function called getUser that returns a type future of type user. We'll create a function that returns a future of type user called getUser. The first thing we'll do is log out the ID that's being passed in. Then we're going to check if the ID is not empty. And if it's not empty, we will get the document for that specific user ID. This will return to us a document snapshot, and we can check if the user exists or not. If the user doesn't exist, we want to log that we have no user with the ID, and we want to return a null value. And to be able to return a null value, we have to make the user type of the future nullable. And like I mentioned, if it doesn't exist, we want to log out that we have no user with the ID in our database. If the user does exist, we want to get that user's data. We'll log out that user information, and then we'll return a user that's serialized from the JSON of that user data. If the user ID is empty, then we want to throw a Firestore API exception, clearly explaining that they have passed in a null or an empty string. That's it for our Firestore API, and that's all that we need now for the user functionality. Next up, we will set up our user service. This class is dedicated to handling anything involving the user. The class will track the current user. It will sync that user's information from the API if it's not available in the current session. And it will also have the functionality to decide if it will create or sync a user profile. In the lib folder, create a new folder called services. And inside of that folder, create a new file called user service. We can go ahead and create the user service class, and then we'll set up our logger. Then we can get the Firestore API from the locator, as well as the Firebase authentication service from our locator. Then we can go ahead and set up the user properties that we'll need outside of the service. The first one is to track the current user, which will be a nullable user. Then we'll set up a property to return this current user as a non-null user. Those are the properties that we'll need for the functionality that we are looking to build. The first function we'll add to this user service is to sync our user account. This function will return future of type void and will be called sync user account. When we start the function, we'll get the Firebase user ID from the Firebase auth's current user. Then we want to log out which user we will be syncing so we can see if we have the correct user ID. Once we have that user ID, we want to get the user's account from the Firestore API. Once we have that user's account, we want to check if it's not equal to null. If it is not equal to null, we want to log out that the account exists, and then we want to save that user account as our current user. The second function, I think I have to explain a little bit before we implement it. Because I have implemented this already, I know what is required. Because we are adding the user sync functionality into the exact same flow for login, sign up, and social sign up, we need a function that can determine if we need to fetch the current user's information or if we have to create a new user account and then save that as the current user's information. The function we are creating next is going to be called sync or create user account. It will take in the user that's created during the auth flow. We will then call the above function that we just created called sync user account. If the current user is still null after we've called sync user account, we have no user account in the database, and then we can use the create user function to create an actual user. This means we'll only call this single function in our auth flow, and that will allow us to either create or sync a user account, but it will ensure that after this function is called, we definitely have a current user set. Now that we have all the tools needed to build out this authentication flow, we can add it into our authentication view model. We'll start by first adding our logger as well as getting the user service from the locator. Then we'll update the save data function to first log out some values. The run busy future function will actually catch any exceptions being thrown by the future that you pass to it, and then it will call the onError function in the view model. That is usually fine, but in this case I actually don't want to execute the handle authentication response when that exception is thrown. So I'm going to ask the run busy future to throw that exception instead of handling it itself. Now that it throws the exception, we need to catch that exception and then set our validation message on it. This is a little tip that I want to share, which is to catch the exact exception that you are expecting. Because of this reason, you will get more crashes during development, but this will allow you to format exactly the exception that's being thrown, to explain exactly to the dev experiencing it what needs to be done to avoid this exception. In this case, we want to catch the Firestore API exception. And then we'll set the validation message equal to that error as well. Now we can go ahead and update our handle authentication response function. First thing we want to do is turn it into a future that returns a void. We also want to add one additional check to see if the user is not equal to null. This should never be the case, but because we are doing the forced non-null value on the auth result.user, I want to make sure that there's no crashes that will be happening. You never know what kind of bugs you can experience from packages developed outside of your current code base. The only additional thing we need to add to our functionality is to sync or create the user account using the user ID and the user email from the auth user. We'll first get that user out of the auth result. Once we have the user, we can call our fancy new function, sync or create user account on the user service. This takes in a user with an ID and an email, and for that we can pass in the UID from the user as well as the email from the user. The rest of the body will stay the same. I want to add some additional logs in case we do get into the else section and it was because the auth result user was null. So in this else check, I want to check if we have no error and if the user is equal to null. If that happens, something is terribly broken in the Firebase package itself, and we need to know about that before we go on a wild goose hunt to find our own bugs. So what we are going to do is we're going to check if there is no error on the auth result and the auth results user is equal to null. If that is the case, we want to log out a WTF log and say we have no error but the user is null. This should not be happening. Then we want to always log out a warning saying that the authentication failed with the auth result error message. Now that we've updated the handle authentication response function to a future, we need to go and await it in every call where it's being called. And before we complete this, we need to register our services that we created in our stacked application. We'll register our user service as a lazy singleton, and then we'll register our Firestore API as a lazy singleton as well. Now that it's all done, we can run our build runner build command. And before you run the code to celebrate your victory, you have to go into your console project on Firebase, and if you haven't clicked on the Get Started button under the Firestore tab, you need to click on the Get Started button under the Firestore tab. I'm going to set up the emulator quickly so that we can run through this and check the logs to see if everything is working as expected. While this starts up, I'd like to mention the things I'm thinking of creating next. The most important thing I want to do next is set up the unit testing, because developing this without unit tests was actually concerning to me. I'm very used to having unit tests confirm that my logic and everything stays correct as I'm refactoring during these tutorials. So in the next episode, we'll set up the unit testing and we'll do a TDD style development to complete the user profile sync on startup. This will allow us to either navigate to the login view or the address selection view based on what's in the user's profile. If you want to see less logs in your console, you can simply type in the filter box Flutter and you'll see only the logs that you add plus some of the logs from the build process. But after the build process is done, you'll never see any other logs besides the logs you add into your code base. So as you can see, this starts up on the login view. I'm going to create an account. The user ID matches from the Firebase ID, so we know we're using the correct user data. Then after the Firestore API completes, we see that it tells us we have no user with the ID in our database. In the sync or create account, our special little function, it now tells us we have no user account, we should create a user. We go ahead and create a user, and then we also log out that the user has been saved. This helps us confirm everything works. But in addition to that, I will open up the console project so that we can go through that and see if the user information is actually on our backend. The first thing we'll do is go to the Authentication tab. Here we should see dane@boxed.com and we should have the ID ZTCBY. That means if we go to our Firestore database, under the users collection, there should be an ID called ZTBCY, which is that one. And the value for that should be dane@boxed.com. So now we can confirm we have our user information when we create a new user account. What about when we log in? We want to make sure that a new account is not created or that there's no clashes, but instead it just syncs our account down. To test that, I'm going to restart the app, and instead of doing a create account, we should now be able to log in using Dane. When I press sign in, we'll see save data again. We'll go to the handle authentication. We see that there's no error. We know what we're going to do here. We do the sync user and we get the user. Then you can see we have user data that has been found, which matches the ones on Firestore. Since the user data has now been found, we can simply save that as our current user. That is the complete flow implemented for user profile management in your Flutter application. This sets the groundwork for us to get a lot closer to the actual food delivery functionality. Next up, we know that it's required for you to have a user address selected before you can use a food delivery service. So once we've set up our unit test and our startup logic for the app, we will get on to doing the address selection using our map, which is going to be a pretty cool function to build. I want to add some cool animations in there as well. So if you want to continue seeing this content, please subscribe. I'll be creating this product throughout the year. Anyway, that's enough from me. Thank you guys for watching, and I will see you guys in the next one next week. Bye bye.